In this video, we will talk about how to determine if a function is a polynomial. So a polynomial is a sum or difference of monomials. Remember, a monomial just means a single term, in which the following two criteria are met. The first is that the exponents are all non-negative integers, so like 0, 1, 2, 3, etc. And the second criteria is the coefficients are all real numbers, so no imaginary numbers, nothing like 5i x to the third or something like that. So no imaginary numbers. So with that in mind, I have 6 examples for us to work through here. Let's check out this first one. Let's say we have f of x is equal to x squared plus 5. Is this function a polynomial? Well, let's check the criteria. The first is that the exponents are all non-negative. So we can see we have an exponent here of 2. It's non-negative and it's an integer, so that's good. And we can see that all of the coefficients, so if we want to imagine that there's a coefficient of 1 right here in front of this x, that's a real number, and so is 5. So we would say that, yes, this function is a polynomial. All right, let's check out number 2. We have f of x is equal to 1/3 x to the 4th plus 2x squared plus 7x. So let's check all the exponents first. We have a 4 right here and a 2. If we want to imagine this one is a 1, all of these are non-negative integers, so that's good. And then we can see that the coefficients 1/3, 2, and 7, those are all real numbers. So again, we would say, yes, this one is also a polynomial. All right, let's check out number 3. f of x is equal to the square root of x minus 5. Now, the square root of x, that can be rewritten as x to the 1/2 power, because the square root is the same as the 1/2 power. So we'll notice that this is not an integer. 1/2 is a fraction. So that means we would say, no, this function is not a polynomial, because all of the exponents have to be non-negative integers. So no fractions are allowed. All right, let's check out number 4. f of x is equal to x plus 5 divided by x squared. We could rewrite this as x plus 5 times x to the negative 2. Because when we have a positive power in the denominator, if we move it to the numerator, it becomes a negative power. So this is the same as x to the negative 2. And the first criteria is that all of the exponents have to be non-negative numbers. So since we have a negative exponent here, we have to say that no, this is not a polynomial. All right, let's check out number 5. f of x is equal to the square root of 10 times x squared. So this 2 right here, that's a non-negative integer as an exponent, so that's good. And this square root of 10 as the coefficient, that's a real number, so it's not imaginary. So the requirements are met. So we would say that yes, this function is also a polynomial. Now remember, the square root, that's only an issue if there's a variable under it. So like an x, we said that could be rewritten as x to the 1/2. But if we just have the square root of 10, so the square root of some number, that's perfectly valid to have. All right, let's check out our last example. f of x is equal to x to the 3/4 minus 1. So we can see that this exponent is not an integer, it's a fraction. So we would say, no, this function is not a polynomial. So those were just a few examples of how to check if a function is a polynomial or not.